Okay, number 5 is y equals e to the negative 5z plus 8 natural log of 2z to the 4th. Okay, so we're just going to take the derivative of each one of these separately. So y prime, the derivative of e to the negative 5z, the e to raise to any power is the derivative is still e to the negative 5z, or whatever it is originally. But then you also have to take the derivative of the exponent and multiply. That's the chain rule. So the derivative of negative 5z is just negative 5. Plus the derivative of 8 times the natural log of 2z to the 4th. Because this is just a number, it's not an actual function, that can just stay. So the 8 just comes down. And then the derivative of natural log is 1 over whatever you're taking the natural log of. So 1 over 2z to the 4th. But then using the chain rule, we also have to multiply by the derivative of 2z to the 4th, which is 8z cubed. Yeah. I feel the same way a lot. We can simplify the way that this looks just a little bit. Rewrite this as negative 5e to the negative 5z. So let's just leave that 8, and then let's multiply this fraction times 8z cubed. All that means is that 8z cubed gets multiplied by the numerator. So this is 8z cubed over 2z to the 4th. That can still simplify. So the 8 is going to stay. We can simplify this fraction. 8 over 2 is 4. Z cubed over z to the 4th is z to the negative 1. When you divide numbers that have the same base, you subtract the exponent. So 3 minus 4 gets you a new exponent of negative 1. Okay, the last thing we can do is multiply 8 times 4, sorry. So that's 32 z to the negative 1. Well, that's the first derivative. We have to find the 4th derivative. Yep. So y double prime. But you can use a 2 as long as it's in parentheses. Yeah, so you could write it like this as well. Either way. Okay, so negative 5e to the negative 5z. The negative 5, since it's just a number, it can just come along for the ride. And then the derivative of e to the negative 5z, we did that in the first derivative also. So it's e to the negative 5z times negative 5. Yeah, it's just gonna, we're just basically gonna be adding another times -5 each time. Okay, the derivative of 32z to the -1st power, the 32 stays, z to the -1st, we use the power rule, so the -1 comes down in front, z, and then we subtract 1 from the exponent. So our new exponent is -2. Okay, -5 times -5 is going to give us a positive 25 e to the -5z. 32 times -1 is going to give us -32 z to the -2 power. Okay, that's the second derivative. On to the third. Good. Okay, third derivative. That 25 is going to stay. The derivative of e to the -5z is e to the -5z times -5. This one, it's the derivative of this exponent. So you're using the chain rule every time. Yeah. That -32 is going to come along for the ride. The derivative of z to the -2, the -2 comes down in front. Our new exponent is -3. Yeah, it's basically a pattern at this point after we got rid of the natural log. So we're going to multiply 25 times -5, -125. And -32 times -2 is positive 64. And now we just have one more to do. The fourth derivative. Yeah, the derivative of e to the -5z is still just e to the -5z times the derivative of -5z, which is -5. We keep the 64, we take the derivative of z to the -3rd, the -3 comes down, our new exponent is -4. -125 times -5. That is positive 625 e to the -5z. 64 times -3 is -192 z to the -4th. There's our answer. Yeah. Okay, number 8. Let me sharpen my pencil. We'll just get them again. You don't like what? Number 8. Q of V equals we don't have to actually. Okay, this one, determine the second derivative. Okay, so we don't have to go as far on these. So the first derivative, and the reason that we don't have to use the quotient rule is because this is not a function in the numerator. It's not a function divided by another function. There's just a number in the numerator. And actually, we're going to rewrite this before we actually take the derivative. So the way that we can rewrite it is we can move everything that's in the denominator up to the numerator. We can do that because everything is being raised to the fourth power. And when we move something either from the denominator to the numerator or from the numerator to the denominator, we can do that as long as we switch the sign of the exponent. So the 2 is going to stay. That 2 from the numerator stays. And then everything from the denominator is coming up to the numerator. And now instead of being raised to the fourth power, it's raised to the negative fourth power. Now we have something that looks like something that we know how to take the derivative of. So again, this 2, because it's not a function, it's just a 2, it's just going to come down to the next line. And then we're going to take the derivative of 6 plus 2v minus v squared raised to the negative fourth power. And we're going to have to use the chain rule. So the outside function is this exponent of negative 4. So we're going to deal with that first. To deal with an exponent, we bring the exponent down in front. So negative 4 comes down in front. 6 plus 2v minus v squared stays the same, and our new exponent is negative 5. Do what? Yeah. Now, the part of the chain rule, after we've taken the derivative of the outside function, we take the derivative of the inside function, which is 6 plus 2v minus v squared, and we multiply. So the derivative of 6 is 0. I'm not going to write that. The derivative of 2v is just 2 minus the derivative of v squared, which is 2v. That v is to the first power because we subtracted 1 from 2, but if you have an exponent of 1, you don't have to write it. Okay, let's simplify as much as we can here before we take the second derivative. We've got 2 times negative 4, which is negative 8, times 6 plus 2v minus v squared raised to the negative fifth, times 2 minus 2v. Okay, we're ready to take the second derivative. Well, we're actually going to have to use the product rule here because there's 2 functions being multiplied together. I'm just not quite understanding how my notes is getting to this. I think maybe they're just skipping some steps. That's fine. Okay, so we're just going to group this -8 in with this first function. So this is our first function, this is our second function, and we're going to use the product rule. Which is this, f prime times g plus f times g prime. So when we take the second derivative, we're taking the derivative of the first function. So in this one, the -8 is going to stay, and then we're going to take the derivative of this function, which we'll have to use the chain rule again to do that. So the derivative of the outside function is the exponent of -5. So we're bringing that -5 down in front. And our new exponent is -6. Then that gets multiplied by the derivative of the inside function, which will be the same as it was before, 2 minus 2v. So that was f prime. Now we have to multiply it by g, the second function, as is, which is also 2 minus 2v. Plus f times g prime. F is -8 times 6 plus 2v minus v squared. And the derivative of g, which is our second function, 2 minus 2v, well, the derivative of 2 is 0. The derivative of -2v is -2. Okay. Let's simplify. We've got -8 times -5, that's +40. We have this 6 plus 2v minus v squared raised to the -6. And let's see, I'm going to do some scratch work to multiply 2 minus 2v times 2 minus 2v. If we use FOIL, we get 4 minus 4v minus 4v plus 2v squared. So that's 4 minus 8v plus 2v squared. Okay. We have -8 times -2, that's a +16 times 6 plus 2v minus v squared. Oh, we forgot something. Wait, no, we didn't. Yes, we did. I did. Right here, -8. This right here, this is our f part of the function. So it's just our first function as is, and I forgot the exponent. So it just should have a -5 here and here. Okay, that wasn't a terrible fix. It is quite a long, messy answer, but that is the answer. All right, number 3 has been requested. I don't know. I've not worked it. It doesn't look too terrible. Or too terribly long, I mean. It's supposed to be X. Okay, so let's first rewrite these terms in a way that makes it look like things that we know how to take the derivative of. So we're going to leave the 4 the same. The 5th root of x cubed is the same as x to the 3/5 power. Whatever your root is, that becomes the denominator of your fractional exponent, and the exponent that's on the x becomes the numerator. Okay, minus 1 over 8x squared. We could write that as 1/8, move the x squared up, and then the exponent becomes negative. So it'll be 1/8 times x to the -2. I don't know why I did this scratch work. I thought it was going to be more complicated than that. Yeah, the other one, it was all of this being raised to the 4th power. Here, it's 8 times x raised to the 2nd power. If it were 8x raised to the 2nd power, that would be different. But right now, in this one, it's only the x that's being squared. No, the square root of x is the same as x to the 1/2 power. And then some more clarification on this middle term. When we move the x squared up to the numerator, you would think that that would be x to the -2 over 8. And that would be correct. But just so for us to be able to take the derivative, it's easier to write the x squared out next to it. You can do that because let's say we have 2 times 4 over 2. That's the same as 8 over 2, which is 4. Or just to prove that these two things are equal, we can write that as 2 over 2 times 4. 2 over 2 is 1 times 4 is 4. So anything in the numerator you can actually write just next to, and it would be the same. That's if everything's being multiplied. If this were 2 plus 4, you could not do that. Okay, now that we've rewritten these, we can take the derivative, f prime of x. Four x to the 3/5 power. The 4 stays. We bring the 3/5 down in front. I don't know which would be easier. I was going to go ahead and multiply, but I'll do the extra steps. And then our new exponent, 3/5 minus 1, is negative 2/5. The minus 1/8 stays. We take the derivative of x to the negative 2, so the negative 2 comes down in front. Our new exponent is negative 3. X to the 1/2 comes down in front. Our new exponent is negative 1/2. That's the first derivative, and we're back in the section where we're asked to find the fourth. We're not ready to find the second derivative yet. Let's multiply here where we can. 4 times 3/5 is 12/5. X to the negative 2/5. Negative 1/8 times negative 2 is positive 2/8, which is 1/4. X to the negative 3. Negative 1/2 times negative 1/2. Oh, sorry. I was trying to take the derivative again. We're not taking the derivative. We're just simplifying. That can't simplify. It's minus 1/2 x to the negative 1/2. Now we're ready to take the second derivative. Okay, I'm going to do some of this multiplication in the same step as when I take the derivative, just because we can. So the 12/5 is going to stay, but it's going to get multiplied by negative 2/5, which would be negative 24 over 10. And that can simplify to negative 6 over 5. Let's double check my mental math here. What are we doing? 12/5 times negative 2/5. Oh, I see what happened. I multiplied the numerators, but I did not multiply the denominators. I added them. So I said 24 over 10 instead of 24 over 25, which is what is correct. Okay. It's still negative though, negative 24 over 25. And our new exponent is negative 2/5 minus 1. 1 can be written as 5/5. So negative 2 minus 5 is negative 7/5. Okay, the 1/4 is going to stay, but the negative 3 is going to come down and multiply. So it's going to be negative 3/4 x to the negative 4th. This one, the negative 1/2 exponent is going to come down in front and multiply by negative 1/2 to get positive 1/4 x to the negative 3/2. That is the second derivative. Third derivative. The negative 7/2 is going to come down and multiply by the negative 24 over 25. That's going to end up being positive. Let me go ahead and just use my calculator. 25 over 24 times 7 over 5. 168 over 125. And our new exponent, -7 minus 5, is -12 over 5. Okay, -4 is going to come down and multiply by -3/4, which is going to just leave us with a +3, x to the -5th. -3/2 is going to come down and multiply by +1/4. That's going to be -3 over 8. And our new exponent is -3/2 minus 1, which is -5/2. One more derivative, sorry. Okay, -12/5 is going to come down and multiply by 168 over 125. So we're going to end up with a negative times 12/5. 2016 over 625. And it's negative. So negative 2016 over 625. And our new exponent is -12 over 5 minus 1, which is -17 over 5. -5 comes down and multiplies by 3 to get -15, x to the -6th. -5/2 multiplies by -3/8 to be a positive 15 over 16. And our new exponent is -5/2 minus 1, which is -7/2. There's our fourth derivative. Okay. Someone asked for number 9, so we'll look at that one next. Okay, h of t equals cosine squared of 7t. We can rewrite this. So we're not taking the derivative yet, just rewriting it as cosine of 7t squared. Okay, this looks like this is going to be a chain rule within a chain rule. So the outermost function is the exponent of 2. So we want to do that first when we take the derivative. The 2 comes down in front. Cosine of 7t stays the same. Our new exponent is 2 minus 1, which is just 1, so we don't really have to write that. That's the derivative of the outermost function. The derivative of the inside function will also use the chain rule because it's not just cosine of t, it's cosine of 7t. So we have to take the derivative of cosine first. Derivative of cosine is negative sine of 7t. And then we have to take the derivative of 7t, which is just 7. So if we simplify this a little bit, we have a +2 times a positive cosine times a negative sine times 7. That's going to be a negative 14. Cosine of 7t, sine of 7t. We only have to find the second derivative on number 9. I just said, since it's a positive times a positive times a negative times a positive, I know the whole thing eventually will end up being negative. So I just pulled that negative out in front. Yeah. Okay. Now it looks like we are going to have to use the product rule because we have a function times a function. So the derivative of the first function, negative 14 cosine of 7t, the negative 14 is going to stay. The derivative of cosine of 7t, we'll have to use the chain rule again. The derivative of cosine is negative sine. And that has to get multiplied by the derivative of 7t, which is 7, times the second function as is, so sine of 7t. Plus the first function as is, which is negative 14 times cosine of 7t, times the derivative of the second function, which is sine of 7t. The derivative of sine is cosine. And then using the chain rule, we have to take the derivative of 7t again, which is 7. Okay. Okay, we have negative 14 times 7 times another negative. So a negative times a negative, that will eventually be positive. And 14 times 7 is 98. So we have a positive 98. And then we have sine times sine. And because it's the same thing inside, it's both sine of 7t. We can write that as sine squared of 7t. Then we have only one negative on this side, so it's going to end up being negative. So we can just write minus. And then we have 14 times 7 again, which is 98. And then we have cosine of 7t times cosine of 7t. That is cosine squared of 7t. That is the second derivative. Okay, so I've done 4. I think that's sufficient. I'd like for you guys to try the rest on your own. Those of you on Zoom, if you want to stay on the Zoom in case you have questions, you can do that. If you want to leave, I understand, you can leave as well. But I think the due date on these is tonight at midnight, so make sure that you get those turned in on Classroom.